and it seems to be working out. It's incredibly sensitive. As soon as I touch it, it triggers the tilt sensor. Hi everyone, welcome to this episode of Think, Learn, Do. For this episode, I wanted to try and prototype an idea I had. I want to make a two-sided dice. And basically with your six-sided dice, you have your sides with all the dots on them. What I want to do is actually make it a two-sided dice, and so what's going to happen is we're going to have 6 LEDs on each side, right? And it's going to be like a coin. And so what you'll do is you'll flip it or throw it or whatever you want to do. And we'll have a little sensor in here somewhere, probably one of my tilt switch sensors. And I'll just detect that motion as it shakes around and bounces around. And once it stops, it'll generate a random number from 1 to 6. And so if you get like 2, it lights up 2 LEDs. And I'll do this on both sides. So whichever way it ends up, it'll show your number. So this shouldn't be too hard to do. I mean, I'm pretty experienced with all of these parts. We're gonna have our 6 LEDs, we'll have some kind of microcontroller in there, a battery of some kind, probably one of the coin cell, and our tilt sensor, which, not very hard. One problem I run into though is with my Holtec chip, I only have like 5 gpios to work with. What we're gonna have to do is, we're gonna have to do something called charlieplexing. And so what charlieplexing is when you have your usual LED, you've got a resistor here. This is going to limit our current so that we don't burn out our LED. We've got our LED over here. That's going to ground, right? So when you turn on your GPIO high, this lights up. And when it's off, this turns off. Pretty simple. So with charlieplexing, we have our pin, a resistor, then our LED, right? But instead of going to ground, it's actually going to go to another GPIO pin. And then we're actually going to have another one like this. So what you can see is when we drive this high, we're going to drive this high and this low, this will light up. Now when we switch it around and we drive this pin high and this pin low, the current's going to flow like this, right? It's going to light this one up. Now because of the nature of a diode, it won't let the current to flow backwards when this one's lit up. So by this way we can control which LED is lit up. Now this doesn't help us much because you can do the same thing with 2 LEDs and 2 pins and get the same effect. It's when we get more pins that this starts to get interesting. Now with 3 pins, we have our 3 GPIOs. And we come over to our resistors. We're going to have our LEDs. Alright, so we have our resistors, we've got our LEDs, and you can see we've got 3 GPIO pins, but we're going to actually be able to drive 6 LEDs, right? So this is a bit of an improvement. So to say we want to turn this LED on, we're going to turn this one high, current's going to flow like this, and then we need to actually turn this one low, right? So current will flow like this, and now this will light up. Now the next problem is, with only the high and the low, if we turn this one high, this one low, and this one low, we'll actually have 2 LEDs light up, right? Because the current will flow like this and like this. So to prevent that, what we can do is actually have this third one be the input pull up, right? Which is the high impedance state. So current will flow from here to here, but it won't flow from here to here because this pin will be in high impedance. So it's basically got a giant resistor over here preventing it from flowing here. So we'll only light up one. So say we want to light up this one, we run this one high, current flows like this, and then we set this one to low, and this one will light up. And this one won't be as big of a deal, but we'll set this to high impedance as well. Now say we want to light this one up, high, and we set this to low, and this high impedance, so it flows like this. So one limitation with this is we can't light up all these LEDs at the same time. So what we'll have to do is we'll have to cycle through them fast enough that it looks like they're all lit up. And if we can hit, I think they were saying around, was it 10 hertz? Anyways, there's some amount of flickering we can do that makes these all look like they're on because the human eye is too slow. So that's the basic introduction to charlieplexing. That's how I'm going to get around the few number of GPIOs I have on this Holtec chip I'm using. So I'm going to prototype this out today, just with the Arduino, because that'll be easier. Make sure I can get something set up so that I can have the 6 LEDs that I need for my two-sided dice. And we'll have the tilt switch on there so we can shake it, make a stop, make sure we light up like we expect with a random number. So let's build that. We're wired up. That was a bit of a brain challenge, but I think I managed to do that right. So now we can try it out with our Arduino, and we'll hook up one of our tilt sensors and try it out. Well, it's doing something. I don't think that's quite what I want it to do. Whoa. That might be, and you can see it flickering here. It's not quite as bad in person. I need to get down the delay on that. For some reason that top one's not turning off, but that might be 4. Okay, those middle two aren't working. So let's debug that real fast. Alright, so did some fun troubleshooting. Turned out I had swapped these two over here. So basically I had 2 from the same pin going to this one, and then 2 from the same pin going to the bottom one. So flipping those around, got it going, or at least showing up. So 1, 2, 3, 4, 5, 6. I should have done that in the first place, but oh well. Okay, so my LEDs are working now. Next up, let's try hooking back up our, well, I guess we can try and get the display looking like I have multiple of these lit up at the same time, and then we'll go back to trying with our tilt sensor. Okay, so this is lighting all 6 at the same time. They look like they're different brightnesses, but I think it's just because of the angle of each one. If I get it right, you can see it looks pretty good. So this is with a delay of 1 millisecond between turning on and off each one, and it looks really good. So that looks like that's going to work. Let's try this again with our random number. Let's see how that turns out. Alright, I've worked through all my code bugs, and it seems to be working out. It's incredibly sensitive. As soon as I touch it, it triggers the tilt sensor. But it is working. A funny thing is that the random number is random. It definitely has a pattern to it. I'm going to have to find a different way to do that. But it does look like it's working, so that's cool. So one thing to note is charlieplexing's pretty confusing, but I did manage to figure it out, so that was great. I don't think I'm going to be directly to the circuit board that I want to make for this just yet. There's a couple of things I want to try first. I'm hoping, and you can kind of see here, I kind of drew this out. I'm hoping to sandwich this between like 3 circuit boards. So the circuit boards I'm using from Osh Park are 1.6 millimeters thick, which is just the right size for a CR2016. I think that's the right battery, but it's 1.6 millimeters thick. So there's going to be circuit board on top, a space in the middle, circuit board on the bottom, and then hopefully that CR2016 will just fit in there. So I'm going to actually make just like a small little prototype to see if that actually works. And then you can see here it's kind of going to have LEDs on the top and LEDs on the bottom, and then the microcontroller here in the middle. So yeah, that'll probably be the next step is prototyping this voltage thing. But yeah, that was fun. I was introduced to charlieplexing. That was the first time I've ever done that. And I'm glad it works. So thanks for watching.